You could have also used trigonometric identities to do this problem in example 1A. So let's go through that particular method. I'm going to start by writing in the fact that the cosecant of theta is -5/2. That's what's given. So the easiest place to start here is with the sine of theta because cosecant and sine are related. So I know to get the sine of theta, I just need to do 1 over the cosecant of theta. Okay, so that's going to be 1 over -5/2. Okay, so we're just basically dividing fractions here. So this is going to be 1 over 1 times, leave the first fraction alone, change the division to multiplication, flip the bottom fraction, okay, multiply across the top and across the bottom. We're going to get that the sine value of theta is -2/5. Okay, remember we're doing 1 over cosecant, 1 over a fraction just flips the fraction. Okay, so our sine value here is -2/5. Okay, we are in quadrant 3 where sine and cosecant values are negative. Okay, moving on. Okay, so now, you can go anywhere from here. You've got these other 4 trigonometric function values you've got to come up with. Just pick something and start. Okay, so I know the sine value now. Okay, and I can relate the sine to the cosine by using a Pythagorean identity. Okay, I know that sine squared theta plus the cosine squared of theta has to equal 1. Okay, let me go back and label these so that the work kind of stays separate. Okay, we know this Pythagorean identity. Okay, we know the value of the sine of theta, so we can plug this in, and that's going to allow us to solve for the cosine. Okay, so using this, okay, we know this is basically saying that if you take the sine of theta and square it, okay, plus the cosine of theta squared is equal to 1. Okay, you don't have to write it this way, but I'm just trying to make it clear to you what is going on. Okay, if I plug in the sine value is -2/5. Okay, if I square that and then add the cosine of theta squared, I should get 1. Okay, if you square a fraction, you need to square the top and you need to square the bottom. Okay, so -2 times -2 is +4. Okay, 5, we've got to square that. 5 times 5 is 25. Okay, so we get 4 over 25 plus the cosine of theta squared is equal to 1. Okay, if we want to solve for the cosine of theta squared, we need to subtract 4 over 25 from both sides. Okay, so I'm going to get that the cosine of theta squared is equal to 1 minus 4 over 25. Okay, so this is going to be 25 over 25 minus 4 over 25, which is 21 over 25. Okay, you could have done this on the calculator. That's perfectly fine. Okay, so then we end up with the cosine of theta squared, which is also cosine squared theta. That is equal to 21 over 25. We want to solve for the cosine of theta, but it's trapped by the square, so we need to take the square root of both sides. Okay, anytime you're taking this, you've got something squared equal to a number and you're using the square root to get rid of the square, you need to put a plus or minus out front on the number. Okay, this tells us on the left the square and the square root will cancel. We'll get that the cosine of theta is equal to plus or minus the square root of 21 over 25. Okay. All right, so this is just a number. We have 2 options for the cosine here. We've got a positive version and we've got a negative version. You absolutely have to pick. You can't have 2 different values for the cosine. Okay, so this is where we bring in the fact that we're in quadrant 3. Okay, in quadrant 3, remember you have negative values for x and negative values for y. And so, since the cosine is associated with the x value, your cosine value should be negative. Okay, so we need to choose the negative version. Okay, so I'm going to say we need to go with negative square root of 21 over 25 because of quadrant 3. Okay. All right. We need to simplify this, meaning we need to rationalize the denominator. Okay. So I'm going to go a step further with this. The cosine of theta is equal to the negative. We need to choose the negative. Okay, if you have the square root of a fraction, you can break it up into the square root of the top over the square root of the bottom. Okay, so that's how this will break down. And then we know that this is going to be the negative square root of 21 over 5. Okay, so we don't have to worry about rationalizing here because we know the square root of 25 off the top of our heads. Okay, so I'm going to go ahead and fill this in. Okay, the cosine of theta is the negative square root of 21 over 5, and I am done with that. Okay, now I can use this to get the secant. Okay, I just need to flip this fraction. Okay, so I'm going to come up here, and our work is kind of running together here. So I'm going to go over here. I'm going to use a different color so I can separate it. If I want the secant of theta, I need to do 1 over the cosine of theta. Okay, so, and I said I was going to use a different color, and then I didn't, so let me do that. All right, so the secant of theta is 1 over the cosine of theta. So this is going to be 1 over negative square root of 25, or sorry, negative square root of 21 over 5. Okay, so again, this is 1 over 1 over negative square root of 21 over 5. Okay, this is going to be 1 times negative 5 over the square root of 21. Okay, this is going to give us multiply across the top, multiply across the bottom. This is negative 5 over the square root of 21. We already knew that without having to do any work because we just flipped the fraction to get the secant. Okay, we do need to rationalize here, so multiply top and bottom by the square root of 21. Okay, so the secant value here is going to be negative 5 square root of 21 over 21. Okay, so let me write that in. All right, so now what's left is just getting tangent and cotangent. Okay, I'm going to go to the next page because I'm out of room. So I'm trying to get the tangent of theta. Okay, so this is basically the fourth trigonometric function I'm trying to find. You need to use some kind of identity that involves the functions that we already know. Okay, well, you know, the Pythagorean identity, there's a Pythagorean identity that's tangent squared theta plus 1 is equal to secant squared theta. We could use that one because we know the information about the secant. Okay, we could also use the fact that tangent of theta is sine theta over cosine of theta. So you have some options here. Okay, I'm gonna go with my old standby sine theta over cosine of theta to calculate the tangent, but again, it's perfectly fine to use tangent squared theta plus 1 is equal to the secant squared of theta. Okay, so I just need to pop in the sine value and divide by the cosine value. So if I go back, okay, remember the sine value is negative 2/5. Okay, so I'm going to put that in. That's going to be in the numerator. The denominator is going to be the cosine value. The cosine of theta is negative square root of 21 over 5. Okay, and that's it. We just need to do the division here and simplify, and that is our tangent value. Okay, so this is a negative divided by negative, so the tangent value will be positive here. Okay, so I'm dividing fractions, so I'm going to leave the first fraction alone, change to multiplication, flip the bottom fraction. Okay, you have a 5 in the top that cancels with 1 in the bottom. This is going to simplify to be 2 over the square root of 21. We need to rationalize, and so multiply top and bottom by the square root of 21. Okay, and now multiply across the top and across the bottom. The tangent of theta is 2 square root of 21 over 21. Okay, so I'm going to go back and fill that in. So 2 square root of 21 over 21. Okay, last trigonometric function we need is the cotangent of theta. So we just basically, you know, we can get that from the tangent value. We just need to flip the tangent value. Okay, so let's go down here and get this. Okay, so the last one, number 5 here, we're trying to compute the cotangent of theta. This is 1 over the tangent of theta. Okay, so this is going to be 1 over, here's the tangent value right here. Okay, so it's going to be 1 over 2 square root of 21 over 21. Okay, let's simplify. Okay, this is going to be 1 over 1 times 21 over 2 square root of 21. Okay, So that's going to be this guy. Okay, so we're going to get 21 over 2 times the square root of 21. Rationalize, multiply top and bottom by the square root of 21. Okay, you're going to get 21 times the square root of 21 over 2 times square root of 21 times square root of 21 is 21. The 21s will cancel. Okay, so the value of the cotangent is the square root of 21 over 2. Okay, here's a little hint. Okay, when you first put the tangent together, okay, you got 2 over the square root of 21, and then you took a step to rationalize. To get the cotangent, the easiest way is to go back to your tangent, but look at it before you rationalize the denominator and flip that. Okay, that will give you the square root of 21 over 2. Okay, so let's go back and fill in the blank, square root of 21 over 2. Okay, we are done. Okay, make sure at the end that all of your signs are correct as far as positive or negative. We are in quadrant 3. So in quadrant 3, the only positive trig functions are tangent and cotangent. Everything else should be negative, and we see that. Okay, if we compare this to the results of doing this by drawing a triangle, if you go back to page 3, you should see that we get the same exact answers. Okay, if you compare between the two, okay, everything looks the same. Okay, I'm just flipping back and forth to make sure. So it's up to you. Again, like I said, go with the method you feel most comfortable with. If you are visual and want to draw a triangle, go that way. If you want to work with the identities, use those.